Good evening, everyone. This is Shambhavi, your physics master teacher. Welcome to Vedantu, Karnataka. Hope my voice and video is clear. So let me just check here as well. Good evening to everyone. How are you all? Hope voice is also clear. If you are there, kindly respond in the chat box. Yeah, I think video is also fine. Yeah. So in today's session, I will be continuing with motion in a plane, which we have, paused in between, and then we just moved on to some one-shot revision sessions. Okay, so I'll continue from there where we have left in the last class. Okay, hope that will be fine in the chapter motion in a plane. Okay, so I think we did 3 sessions on this motion in a plane. So we understood more about vectors, vector mathematics, and then we had moved on to how to represent a motion in a plane, and then we have moved on to projectile motion. So with a quick recap in terms of projectile motion, I will continue from today. Okay, I'll just give you a quick recall till where we have discussed in projectile motion. So if you can recall, we discussed that we can represent the trajectory of a projectile as a parabola. Okay, the trajectory of a projectile comes out to be a parabola. So that part we have proved, and we also obtained the expression for time of flight. Okay, so I'll quickly recollect these 2 points because this is anyway very important, and to go ahead with maximum height of the projectile, horizontal range of the projectile, and problems. So we need these initial equations which we have earlier derived. Okay, so I'll give you a quick revision of that part, and then I will move ahead for today's topic. Hope that will be fine with you all. Yes, kindly respond in the chat box. I'm just waiting for your response. Okay, so we know what is a projectile or a projectile motion is. So an object that is in flight after being thrown or projected at certain angle with respect to the horizontal, we call it as projectile, and after it is being thrown, it is only acted by gravity. Okay, we consider the effect of gravity only here. Okay, so that is what is a projectile motion. And we also looked about some examples like if you throw a ball, or it's like if you kick a football, and cannon shots. All these are going to be some examples. And also, if you can recall with our previous class, we know that the trajectory, like once you kick this ball, we know that it takes a parabolic path. So we have proved that. So now to have a quick revision, so I'll take the basics of this projectile motion, and then we'll go ahead for today's topic. So to give you the quick recall, I just have collected whatever we had written in our previous classes on this chapter, motion in a plane. So ಏನು ಮಾಡಿದ್ವಿ ಅಲ್ಲಿ, so we had something like if I throw some object, it might be any object, a stone, a ball, or anything. So let us say we are throwing this object at some initial velocity as u at an angle theta with respect to the horizontal. So when we throw at some angle, we found that it is going to take a parabolic path. So here our first job is to, it's a motion in a plane, right? It is in 2 dimension. So ಇಲ್ಲಿ ಏನ್ ಮಾಡ್ತೀವಿ ನಾವು, we resolve it into 2 simultaneously occurring 1D motion. So ಏನ್ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ, one motion along horizontal direction ಇದೆ, another motion along vertical direction ಇದೆ. So ಆ ತರ equations ಬರಿತೀವಿ. That is our idea of, writing the equations. It may be velocity or the displacement, accelerations along the mutual perpendicular coordinates. Okay, so that is the that is from your resolving of vectors it is possible. If you can recall, we know that any vector can be resolved into their orthogonal components or perpendicular components. So from that we can consider this motion in a plane as a 2 simultaneously occurring motion in 1 dimension, which are occurring simultaneously andre at the same time ಆಗ್ತದೆ and in the perpendicular direction ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, ಸೊ ಏನ್ ಮಾಡ್ತೀವಿ ಅವಾಗ, ಅಲಾಂಗ್ ಎಕ್ಸ್ ಆಕ್ಸಿಸ್ ಗೆ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಇಕ್ವೇಶನ್ಸ್ ಬರೀತಾ ಹೋಗೋಣ, ಅಲಾಂಗ್ ವೈ ಆಕ್ಸಿಸ್ ಗೆ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಇಕ್ವೇಶನ್ಸ್ ಬರೀತಾ ಹೋಗೋಣ, and then we'll get the expression for trajectory. Trajectory ಅಂದ್ರೆ, so how y coordinate changes when x take certain values. Okay, x change ಆದಾಗ y coordinate ಹೇಗೆ ಚೇಂಜ್ ಆಗುತ್ತೆ, so that is going to give you the trajectory equation. Okay, so that is the first part in this projectile motion, which can be asked in 3 marks or 5 marks. Okay, depends on paper to paper. In 3 marks, if they ask, it's just to obtain any one of the equation, like trajectory is a parabola or maximum height or range or any one they will ask. If for 5 marks means definitely 2 quantities will be asked. Okay, so hope you're following. Hello Suman, hope you're following. Yeah, if you're just following, give me a thumbs up there, and any doubts please let me know as well. So we are quickly recollecting projectile motion. You can consider this as a regular chapter or a revision for your upcoming test. Okay, so projectile motion is one of the important concept in your motion in a plane. Okay, yeah, hope there are no doubts. Yeah, I think I'll just go ahead. If any doubt at any point of time, please feel free to ask, and if you're following and you're understanding, please give me a thumbs up. Also you can like the video so that I'll get to know that you're following. Okay, yeah, so first thing, we know that our initial velocity we have taken it as u, correct? So we will resolve it into 2 components, one along x-axis, which is our u cos theta, the other along y-axis, which is our u sin theta. This is the initial velocity. So what is this u? This is the initial velocity with which we are projecting the projectile. Okay, so alli enagide, initial velocity u cos theta ide. Along horizontal direction, do we have any acceleration? No. Just once we throw the object, I have repeatedly telling you that it is only acted by gravity. Gravity will always act vertically downward. Okay, so along the x-axis there is no acceleration. Okay, so along x-axis now ಏನು ಹೇಳ್ಬೋದು, the motion is just a uniform motion. Along x-axis we will just have a uniform motion. Andre the particle along horizontal direction, it just moves with a constant velocity anta artha. Okay, so now at any point of time, what is the velocity of the particle along x-axis andre heng baritivi? So we can say v is equals to u plus at namige gottide. So idara components along x-axis tagonodu henge, vx is equals to ux plus ax into t agutte, but ax 0 irodrinda this whole term goes to 0. We simply get like vx is equals to ux, so which is nothing but equal to u cos theta. Okay, so along the horizontal direction, the particle just moves with a uniform velocity of u cos theta. Okay, and now if I want to find out at some point of time what is x coordinate of the particle, so for that what equation we can use? So that is like x is equals to ut plus half at square. These are all from our 1D equation only I am taking, but we had to write with the component notation, u suffix x, ax, ay, vx, vy, like that. Okay, so illenagide again acceleration 0 irodinda the second term goes to 0, so we get x is equals to ux into t. Okay, so that equation is here, which will give us u cos theta into t. So I'll just write that here. I need that equation. So enagirutte x equals to u cos theta into t. Okay, or from here we get an expression for time as x by u cos theta. This we need it for later point of time. Okay, and then similarly we'll try to find out what is the velocity of the particle along y axis at some, after some time. At the same time, what is the position of the particle along y axis after some time t. So ಅದೆರಡು equation ಬರಿಬೇಕು. So for that same steps ಏನು ಮಾಡೋಣ, initial velocity along y axis is u sin theta, which we clearly know, correct? Uy is u sin theta, and along y axis do we have any acceleration? So definitely yes, it is acceleration due to gravity and it is acting downward, so I will be taking minus g. Okay, hope it is clear till here. Yes, good evening, very good evening. What's your name? Chinni Ammu, I think you have mentioned like something in last class, I just forgot, Niriksha or something maybe. Anyway, yes, good evening to everyone. I think somebody has a doubt, that is Rakshita. Path traveled by a parabola. Okay, see, the point is, it is not path traveled is parabola. Okay, hope you agree, Rakshita, that if I say I throw a ball at certain angle, so definitely it takes a parabolic path. I think you have no doubt in saying that it takes a parabolic path, correct? Yes, Rakshita, you can tell me yes or no there in the chat box. Okay, so the next thing is, yeah, if you are there, please respond. I'm just looking for your message there. Okay, so the point is, we are looking for a trajectory equation. Path henge yav tara irutte anta. Path andre enu, so we need to have, or we need to get their x and y coordinates. Trajectory andre physics ಅಲ್ಲಿ ಬೇರೆ ಇನ್ನೇನು ಅಲ್ಲ, y coordinate ಮತ್ತೆ x coordinate ಮಧ್ಯೆ ಇರೋ ರಿಲೇಷನ್. ಓಕೆ, ಅದನ್ನ ನಾವು ಟ್ರೆಜೆಕ್ಟರಿ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಈಗ ನಾವು if we just throw a ball, we see that it takes a parabolic path, correct? So ಅದರ ಟ್ರೆಜೆಕ್ಟರಿ ಈಕ್ವೇಷನ್ ಅನ್ನು ನಾವು we are trying to derive here. Okay, so first step ಏನು, okay, ನಂಗೆ x and y coordinate ಬೇಕು ಅಂದ್ರೆ, so what I will do, first I will try to write this x and y equation from 1D motion. So I know that x is equals to ut plus half at square also I know, and velocity equation also I know. I consider these two very basic equation. So first step ಏನು ಮಾಡಿ, if it comes in exam or if you are having some doubts here, first velocity ಮತ್ತೆ ಪೊಸಿಷನ್ ಅಂದ್ರೆ ಏನಿಲ್ಲಿ 1D ಅಲ್ಲ 2D, ಸೊ ಎಕ್ಸ್ ಮತ್ತೆ ವೈ ಎರಡರ ಪೊಸಿಷನ್ ಬೇಕು ನಿಮ್ಗೆ. ಓಕೆ, ಸೊ ಅದನ್ನ ಬರ್ಕೊಳ್ಬೇಕು. ಸೊ ದಟ್ ಈಸ್ ದ ಫಸ್ಟ್ ಸ್ಟೆಪ್. ಓಕೆ, ಸೊ ಅದನ್ನೇ ನಾನಿಲ್ಲಿ ಮಾಡಿರೋದು, ವಿ ಎಕ್ಸ್ ಗೆ ಒಂದು ಇಕ್ವೇಶನ್ ಬರ್ದಿದ್ದೀನಿ, ಯು ಎಕ್ಸ್ ಗೆ ಬರ್ದಿದ್ದೀನಿ. ಅದೇ ತರ ನೆಕ್ಸ್ಟ್ ಏನ್ ಮಾಡ್ತೀನಿ, ವಿ ವೈ ಒಂದು ಇಕ್ವೇಶನ್ ಬರೀತೀನಿ, ಅಂಡ್ ದೆನ್ ವೈ ಒಂದು ಇಕ್ವೇಶನ್ ಬರೀತೀನಿ. ಓಕೆ, ಯಾ, ಇಸ್ ದಟ್ ಫೈನ್ ರಕ್ಷಿತಾ? Okay, so the next thing is, once you get your vy and yx and vx equation, so next ನಾವು ಟೈಮ್ ಇರುತ್ತಲ್ಲ ಅದನ್ನ ಎಲಿಮಿನೇಟ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಟೈಮ್ ಅನ್ನ in terms of some other quantity we have to substitute. That is the second step. So that I am explaining to you now. Okay, hope there is no doubt till writing vy as uy plus ayt. Again same equation, v is equals to u plus at ನೇ ಕಾಂಪೊನೆಂಟ್ ನೋಟೇಷನ್ ಅಲ್ಲಿ ಅಲಾಂಗ್ y axis ಗೆ ಬರ್ದಿದ್ದೀನಿ, ಬಟ್ ಇಲ್ಲಿ ಆಕ್ಸಿಲರೇಷನ್ 0 ಅಲ್ಲ, ದಟ್ ಈಸ್ ay is minus g, that I am keeping as it is. Okay, so u sin theta minus gt. Obviously it is there for NEET. Okay, and The next thing is, once you get velocity of the particle after some time, next step kelsa eno, we had to write down what is the position along y-axis after some time. So similarly, x is equals to ut plus half at square inde ಅದೇ ತರ y ಗೆ ಬರೀರಿ. ಸೊ y ಹೆಂಗ್ ಬರೀತೀರಾ? y is equals to uy into t plus half ay into t square ಅಂತ ಬರೀಬಹುದು. ಬಟ್ ಇಲ್ಲಿ ay ಅಂದ್ರೆ ಏನ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಬೋದು? Acceleration due to gravity, that is minus g ಅಂತ ಬರೀಬಹುದು. Okay, so this is my, the position of the particle along y direction after some time t. So I'll consider that as well. So in mana y is equals to uy is u sin theta, okay, uy into t minus half gt square. Okay, is that clear? So uy into t ಇದೆ. So uy ಅಂದ್ರೆ ಏನು substitute ಮಾಡ್ಬೋದು? u sin theta along y axis. So what is the initial velocity component? That is u sin theta. So u sin theta into t minus half gt square ಆಯ್ತು. ಸೊ ಈಗ ನಂಗೆ x ಗೆ ಒಂದು ಈಕ್ವೇಶನ್ ಬಂದಿದೆ, y ಗೆ ಒಂದು ಈಕ್ವೇಶನ್ ಬಂದಿದೆ, ಬಟ್ ಇದು ಟ್ರೆಜಾಕ್ಟರಿ ಈಕ್ವೇಶನ್ ಆಗಲ್ಲ, ಎರಡು ಸಪರೇಟ್ ಈಕ್ವೇಶನ್ ಇದೆ. ಟ್ರೆಜಾಕ್ಟರಿ ಅಂದ್ರೆ x ಚೇಂಜ್ ಆದಂಗೂ y ಹೆಂಗ್ ಚೇಂಜ್ ಆಗತ್ತೆ ಅಂತ ಬೇಕು. ಸೊ ಫಾರ್ ದಟ್ ವಾಟ್ ವಿ ವಿಲ್ ಡೂ ಇಸ್ ವಿಲ್ ಪುಟ್ ದಿ ವ್ಯಾಲ್ಯೂ ಆಫ್ t or we'll eliminate t in this y equation. Okay, so substitute ಮಾಡಿದ್ರೆ ಆಯ್ತು from equation 1. Okay, so ಏನು substitute ಮಾಡ್ಬೋದು? y is equals to u sin theta into t ಅಂದ್ರೆ ಏನು ಹಾಕ್ಬೋದು? x by u cos theta minus half into g into t square ಇದೆ, that is like x square by u square cos square theta. Okay, is that fine? Hope you are all following. Okay, so next ಏನು ಮಾಡಬೇಕು? Simplify ಮಾಡಿದ್ರೆ ಆಯ್ತು. y is equals to, so this u and this u will cancel out. Sin theta by cos theta will give us tan theta. So ಇಲ್ಲಿ ಒಂದು x ಇದೆ, so I can write like x tan theta minus half, or I'll just write like g by 2u square cos square theta into x square. So this is the standard representation of the trajectory of a projectile. I think you are asking for this equation. So till here 3 marks. Okay, prove that the trajectory of a projectile is parabola andre illi tanka baribeku. So this is representing a parabola anta nange henge gottagatte? Because from maths we know that there is a standard representation for a parabola. Okay, so general representation ಏನು? y is equals to ax plus bx square ತರ ಇದ್ರೆ. Okay, so this is a parabola equation. ಈ ಫಾರ್ಮಲ್ ಇದ್ರೆ ಪ್ಯಾರಾಬೋಲಾ ಅಂತ ಕರಿತೀವಿ. ಓಕೆ, ಸೊ ಇಲ್ಲಿ x ಸ್ಕ್ವೇರ್ ಟರ್ಮ್ ಇದೆ, x ಇಲ್ಲ. ಇಫ್ ಇಟ್ ಇಸ್ ಜಸ್ಟ್ ಲೈಕ್ ax, then it is a linear or a straight line. ಸೊ ಆಗ ನಾವು ಹಿಂಗ್ ಥ್ರೋ ಮಾಡಿದ್ರೆ ಸ್ಟ್ರೇಟ್ ಆಗೇ ಹೋಗ್ಬೇಕಿತ್ತು, ಬಟ್ ಇಲ್ಲಿ ಸ್ಟ್ರೇಟ್ ಆಗಿ ಹೋಗ್ತಿಲ್ಲ. It is taking a parabolic path. Okay, so this is how we get the trajectory of a projectile. Hope it is clear till here. Any doubt, please ask in the chat box. And you can stick to the academic doubts in the chat box instead of wasting your time in chatting something else. And Rakshita, hope it is clear to you. If you are still there, please respond. Yeah. Okay. So ಇಲ್ಲಿ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ you can clearly tell that a ಅಂದ್ರೆ ಏನಿದೆ? tan theta ಅಂತಿದೆ, and I can say b ಜಾಗದಲ್ಲಿ ಏನಿದೆ? minus g by 2 u square cos square theta. Okay, so it is clearly representing a parabola, and hence we say the trajectory of a projectile is parabola. Hope it is clear till here. If you are there, respond in the chat box. And now we'll just quickly move on to the next part. That is, one is time of maximum height, the other is time of flight. So ಇಲ್ಲಿ ಎರಡು ಡಿರವೇಶನ್ ಇದೆ. ಟೈಮ್ ಆಫ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಹೈಟ್ ಅಂದ್ರೆ, ಸೊ ಹೌ ಮಚ್ ಟೈಮ್ ಡಸ್ ದ ಪಾರ್ಟಿಕಲ್ ಟೇಕ್ ಟು ರೀಚ್ ಟಿಲ್ ದಿಸ್ ಪಾಯಿಂಟ್. ಓಕೆ, ಸೊ ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಹೋಗಕ್ಕೆ ಎಷ್ಟು ಟೈಮ್ ತಗೊಳುತ್ತೆ. ಓಕೆ, ಸೊ ದ್ಯಾಟ್ ಇಸ್ ಟೈಮ್ ಆಫ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಹೈಟ್, ಟೈಮ್ ಟು ರೀಚ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಹೈಟ್. Okay, time to reach maximum height. So time to reach maximum height andre I have told you this also in our previous class. So ಇಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ at maximum height, okay, the velocity along y axis is 0, vy 0 ಆಗುತ್ತೆ. ಏನಾಗಿರುತ್ತೆ velocity along y axis 0 ಆಗಿರುತ್ತೆ. ಓಕೆ, at maximum height vy is equals to 0 ಆಗಿರುತ್ತೆ. ಸೊ ಆ ಟೈಮನ್ನ ನಾವು tm ಅಂತ ತಗೊಳ್ಳೋಣ. ಟೈಮ್ ಟು ರೀಚ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಹೈಟ್ ನ tm ಅಂತ ತಗೊಳ್ಳೋಣ. ಓಕೆ, ಸೊ ಈಗ ಏನ್ ಮಾಡೋಣ, ವಿಲ್ ಜಸ್ಟ್ ಗೆಟ್ ಬ್ಯಾಕ್ ಟು ಅವರ್ ಪ್ರೀವಿಯಸ್ vy ಈಕ್ವೇಶನ್. ಏನಿದೆ ಇಲ್ಲಿ u sin theta minus gt ಅಂತಿದೆ. ಸೊ ಐ ವಿಲ್ ಕನ್ಸಿಡರ್ ದಟ್. ಸೊ we know that, ಸೊ ಏನಿದೆ vy is equals to u sin theta minus gt ಅಂತಿದೆ. ಕರೆಕ್ಟ್? ಸೊ ನಾವು ಏನ್ ಹೇಳ್ಬೋದು, at t is equals to tm ಆದ್ರೆ vy will be equal to 0 ಆಗುತ್ತೆ. ಸೊ this implies, ಇಲ್ಲಿ ಮೇಲ್ಗಡೆ ಇಕ್ವೇಶನ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ vy 0 ಆಗುತ್ತೆ. ಸೊ ಆಗ ಏನ್ ಬರುತ್ತೆ ನಮ್ಗೆ, u sin theta minus gtm will be equal to 0. Just put t is equals to tm, vy equals to 0. That's all I'm doing. Because at maximum height, the vertical component of velocity of the particle is 0. ಅಲ್ಲಿ 0 ಆಗಿರ್ಲಿಲ್ಲ ಅಂದ್ರೆ ಪಾರ್ಟಿಕಲ್ ಇನ್ನೂ ಮೇಲೆ ಹೋಗ್ತಿತ್ತು, ಹಿಂಗ್ ಕೆಳಗ್ ಬರ್ತಿರ್ಲಿಲ್ಲ ಇಲ್ಲಿ. ಓಕೆ, ಇಫ್ ಇಟ್ ಇಸ್ ಕಮಿಂಗ್ ಡೌನ್ ಮೀನ್ಸ್ ಅಟ್ ದಟ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾಯಿಂಟ್ ವೆಲಾಸಿಟಿ ಅಲಾಂಗ್ ವೈ ಆಕ್ಸಿಸ್ 0 ಆಗಿದೆ. ಟೋಟಲ್ ವೆಲಾಸಿಟಿ 0 ಆಗಿಲ್ಲ, ಬಿಕಾಸ್ at that point the total velocity of the particle will be simply equal to the horizontal component of velocity ಆಗಿರುತ್ತೆ, that is u cos theta. Okay, so ಆ ಪಾಯಿಂಟ್ ನಿಮಗೆ ಗೊತ್ತಿರಬೇಕು. at maximum height v is equals to u cos theta ಆಗಿರುತ್ತೆ, that is total velocity, but velocity along y axis 0 ಆಗಿರುತ್ತೆ. Okay, is that fine? So from here we get tm equals to, so u sin theta by g. Okay, tm will be equal to u sin theta by g ಆಗಿರುತ್ತೆ. Okay, this is the time to reach maximum height. So ಈಗ ಏನಾಗಿರುತ್ತೆ, for the particle, if it is going from here to here, it is taking some time like tm. ಸೊ ಅಲ್ಲಿಂದ ಕೆಳಗೆ ಮತ್ತೆ ಗ್ರೌಂಡಿಗೆ ಬರಕ್ಕೆ ಸೇಮ್ ಟೈಮ್ ತಗೊಳುತ್ತೆ. ಸೊ ಟೋಟಲ್ ಟೈಮ್ ಆಫ್ ಫ್ಲೈಟ್ ಏನಾಗಿರುತ್ತೆ, ಇಟ್ ಇಸ್ 2 times the time to reach the maximum height ಆಗಿರುತ್ತೆ. ಸೊ ದಟ್ ಈಸ್ ಅವರ್ ಟೈಮ್ ಆಫ್ ಫ್ಲೈಟ್. ಸೊ ಇಲ್ಲಿ ಟೈಮ್ ಆಫ್ ಫ್ಲೈಟ್ ಅಂದ್ರೆ ಏನ್ ಹೇಳ್ಬೋದು, ಟೋಟಲ್ ಟೈಮ್. ಓಕೆ, ಟೈಮ್ ಆಫ್ ಫ್ಲೈಟ್ ಅಂದ್ರೆ ಅದು ಟೋಟಲ್ ಟೈಮ್ ಟು ಗೋ ಫ್ರಮ್ ಪಾಯಿಂಟ್ ಆಫ್ ಪ್ರೊಜೆಕ್ಷನ್ ಟು ರೀಚ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಹೈಟ್ ಅಂಡ್ ದೆನ್ come back to the ground again. So this total time will be equal to what? So idunna now capital T inda represent ಮಾಡ್ತೀವಿ. Okay, so let me just write here. So ಏನಾಗಿರುತ್ತೆ, capital T just a second. Yeah. So ಏನು ಹೇಳ್ಬೋದು, capital T is equals to 2 times the time of flight ಆಗಿರುತ್ತೆ, or this will give us T is equals to 2u sin theta by g ಆಗಿರುತ್ತೆ. Okay, 2u sin theta by g. Hope it is clear. Any doubts, please ask in the chat box. Hope all of you are following. Okay, T is equals to 2u sin theta by g. This is one equation which can be asked again in 3 marks or your 5 mark question. Okay, time of flight, time to reach maximum height. So time to reach maximum height ಅಂದ್ರೆ ಏನಾಗಿರುತ್ತೆ, at maximum height position velocity along vertical direction, that is along y axis 0 ಆಗಿರುತ್ತೆ. So ಆ equation ತಗೊಂಡು you can arrive, and then time of flight is the 2 times the time to reach the maximum height. So ಆ ಪಾಯಿಂಟ್ ಗೊತ್ತಿರಬೇಕು. ಇನ್ನೊಂದು ಮೆಥಡ್ ಇದೆ, ಸೊ ಐ ಜಸ್ಟ್ ಗಿವ್ ಇಟ್ ಯು, ಯು ಕ್ಯಾನ್ ಟ್ರೈ ಇಟ್ ಔಟ್ ಯುವರ್ ಸೆಲ್ಫ್. ಸೊ ಏನ್ ಮಾಡ್ಬೋದು, ಸೊ ಟೋಟಲ್ ಟೈಮ್ ಆಫ್ ಫ್ಲೈಟಿಗೆ, ಓಕೆ, ಸೊ ಇಲ್ಲಿ ದ ಪಾರ್ಟಿಕಲ್ ಹ್ಯಾಸ್ ಸ್ಟಾರ್ಟೆಡ್ ಫ್ರಮ್ ಹಿಯರ್, ಇಟ್ ಗೋಸ್ ಟು ದಿಸ್ ಪಾಯಿಂಟ್, and then it comes back here. So at this point, the value of y will be 0. Okay, so once it comes back to the ground, adara y axis coordinate 0 ಆಗಿರುತ್ತೆ. So ಆಗ ಏನು ಮಾಡ್ಬೋದು, we can say this equation. Okay, y equals to, so ಆ equation consider ಮಾಡಿದ್ರೆ y is equals to u sin theta into t minus half gt square ಇದೆ. So ಇಲ್ಲಿ when small t is equals to capital T, that is when the time is equals to the time of flight, so y value ಏನಾಗಿರುತ್ತೆ 0 ಆಗಿರುತ್ತೆ. So equate this to 0, this whole thing again ಬರುತ್ತೆ ನಿಮಗೆ. So I'll directly write it. You get something like half g capital T square is equals to u sin theta into capital T ಆಗುತ್ತೆ, or so ಇಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ 1t and here 1t will go away, so you will get back the same equation. So you know capital T is equals to 2u sin theta by g. Okay, so this is the expression for time of flight. Another method you can do either way. Okay, so capital T is equals to 2u sin theta by g. Okay, follow whichever you want, whichever is the easier one. Okay, another method to obtain the time of flight. Hope it is clear to everyone. Any doubt, you can respond. Yeah, so next is to get, yeah, from here we had to derive it freshly. So that is maximum height of a projectile. Okay, so what is the expression for this h anta kelidare. Okay, so maximum height na usually capital H inda represent ಮಾಡ್ತೀವಿ, or you can write like h max, that's your choice. Okay, so maximum height of a projectile h. Okay, so it is the maximum vertical height reached. Okay, so what is this vertical length from ground reference to this reference, what is the vertical height attained by the projectile, so adana maximum height anta consider ಮಾಡ್ತೀವಿ. Okay, so ಈಗ there are again, what you can do is, again we say at the maximum height position. Okay, so maximum height position ಅಲ್ಲಿ velocity along y axis 0 ಆಗಿರುತ್ತೆ. Okay, and what else we can say is, if I consider my y equation, so I'll just reconsider this. Okay, I'll call this as equation 2. Okay, so from 2, so ಏನು ಹೇಳ್ಬೋದು, from equation 2, so ಏನು ಹೇಳ್ಬೋದು, y is equals to, so I'll just rewrite that, u sin theta into t minus half gt square ಇದೆ. Okay, so at maximum height ಏನಾಗಿರುತ್ತೆ, y will be equal to this height h ಆಗಿರುತ್ತಾ, so I can say at maximum height. Okay, so ಏನಾಗಿರುತ್ತೆ, y will be equal to h, and ಅದಕ್ಕೆ corresponding time ನಮಗೆ ಗೊತ್ತಿದೆ, so we can substitute the value for t. So t value ಏನಾಗಿರುತ್ತೆ, tm ಆಗಿರುತ್ತೆ, because the particle takes a time equals to time to reach maximum height, that is tm ಅಂತ ನೋಟೇಟ್ ಮಾಡಿದೀವಿ. ಅದಕ್ಕೊಂದು equation ಬಂದಿದೆ, that is u sin theta by g. Hope you agree. So here itself we have derived tm is equals to u sin theta by g. So that is the time to reach the maximum height. Okay, so ಅದನ್ನು substitute ಮಾಡೋಣ. ಏನು ಬರುತ್ತೆ ನಮಗೆ, y is equals to u sin theta into t ಅಂದರೆ u sin theta by g minus half g into t square ಅಂದರೆ u square sin square theta by g square ಆಗುತ್ತೆ. Okay, so again ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ, yeah, so here I can say this y is h, no, we can put y as h. So what I'm doing, I'm putting y as h, that is at that particular height, the y coordinate will be equal to the maximum height reached h, that is the notation we use. So h agatte, and time again substitute ಮಾಡಬೇಕು, the time taken by the particle to reach the maximum height, which is u sin theta by g. Don't put 2u sin theta by g. 2u sin theta by g is to go from this point and to come back to ground reference again. Okay, so illi simplify ಮಾಡಿದ್ರೆ, so u square sin square theta by g minus, so here 1g and here 1 power of g will go away, minus u square sin square theta by 2g. So ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿ, u square sin square theta by g ಇದೆ, ಇಲ್ಲೂ u square sin square theta by g ಇದೆ and half ಇದೆ, correct? It is like 1 minus half ತರ ಇದೆ, correct? So u square sin square theta minus half times the u square sin square theta by g ತರ ಇದೆ, that means 1 minus half ಅಂದ್ರೆ half ಆಗಿರುತ್ತೆ. So you can clearly tell that, so the expression for maximum height reached h is equals to u square sin square theta by 2g. Okay, or you just imagine like u square sin square theta by g na common ತಗೊಂಡ್ರೆ 1 minus half ಬರುತ್ತೆ, 1 minus half will give you half, so that 2 is coming here. Okay, u square sin square theta by 2g is the expression for maximum height reached. Okay, is that clear? So any doubt, please let me know in the comment section, in the chat box. Okay, so I think there are no doubts, we can just go ahead. So this again, only the maximum height part can be asked for 3 marks, or they may club with any other part and can be asked in 5 marks. So just remember, height is like some position we are finding out, vertical position. So I am considering the y equation. Okay, so vertical height ಅಥವಾ vertical position ಬೇಕಂದ್ರೆ y equation ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕು. ಅದೇ ತರ ಹಾರಿಜಾಂಟಲ್ ಕೋಆರ್ಡಿನೇಟ್ ಏನಾದ್ರು ಬೇಕಾಗಿದ್ರೆ ನಾನು x equation ತಗೊಳ್ತಾ ಇದ್ದೆ. So that will be your starting step. So next step ಅಲ್ಲಿ ಏನು ಮಾಡ್ತೀರಾ, as we are talking about the maximum height of the projectile, so time ಗೆ substitute ಮಾಡ್ತೀವಿ. So ಆ time ಏನಾಗಿರುತ್ತೆ, what is the time taken by the particle to reach the maximum height? It is nothing but u sin theta by g. So ಅದನ್ನ substitute ಮಾಡೋದಷ್ಟೇ. So next is just the simplification. Okay, so going ahead to the next point. So here itself you can take like a note. So this is just an extra point I'm giving it to you. So let us consider the expression for maximum height h, which we got it as u square sin square theta by 2g. Okay, so maximum height is u square sin square theta by 2g. So now for what angle of projection height reached will be maximum? Okay, because if you just consider, okay, so maybe at some angle of projection the the particle may take some height like this, or I may find something like this where the maximum height reached is this much. Okay, so for different angles of projection, okay, so let me say this is theta 1, this is theta 2. Okay, for different angle of projection, the height reached will keep on changing. Hope you agree that. So from here it is very clear that h is proportional to sin square theta anta helbodu, correct? H is proportional to sin square theta anta consider ಮಾಡಬಹುದು. So from that fact, if we consider, okay, for what angle of projection the height reached is maximum. Okay, so that we'll try to find out. Okay, for height to be maximum, okay, so ಏನಾಗಿರುತ್ತೆ, u, it depends on at what velocity you are throwing. Let us say u is fixed. Okay, for u fixed, that is the initial velocity. Okay, initial velocity or initial projection speed na fix ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ. So for u fixed, if you observe, this g is also constant, acceleration due to gravity. 2 is just a number, again a constant. So we can clearly say that h is directly proportional to sine square theta ಆಗಿರುತ್ತೆ. So ಈಗ for height to be maximum, sine square theta should be maximum. Hope you agree. Sine square theta should be maximum. Okay, so yavaga sine square theta maximum agutte, we know that the maximum value a sine can take is 1. Okay, sine value varies from -1 to +1. So the maximum value it can take is always +1. Okay, so ಏನು ಹೇಳ್ಬೋದು, sine square theta is equals to +1 ಆಗಿರಬೇಕು, or in other words sine theta is also equal to +1 because root ತಗೊಂಡ್ರೆ sine, root of 1 is 1 itself. So sine theta is equals to 1, or this will give you theta is equals to sine inverse 1. So inverse trigonometric function, correct? And what is the value of sine inverse 1? It is nothing but pi by 2 or 90 degree. So ಏನಾಗಿರುತ್ತೆ, at an angle of projection 90 degree, that means vertically upward throwing like this. Okay, not throwing at an angle, so you are throwing vertically upward. In that case the height reached by the particle will be maximum. Okay, so henge condition eno, condition sine square theta maximum agbeku, because u and g are fixed. U is fixed for a given case. Like for me there is a limit at what maximum speed I can throw. So for a given situation u is always constant, but for the same u I can throw at different angle. Hope you agree, correct? So for in that situation, at what angle the height reached is maximum? For an angle equal to 90 degree, that is vertical projection. So aga height reached will be maximum. Okay, so it is, hope you know little bit about inverse trigonometric functions. It's just like sine 91 adre adra inverse value sine inverse of 1 ಏನಾಗಿರುತ್ತೆ 90 degree ಆಗಿರುತ್ತೆ. Okay, it's an inverse trigonometric function. I think you are little bit familiar about inverse trigonometric function for now. Or it's like just to give you one more example, we know that sine 30 andre half, ಅದೇ ತರ sine inverse half ತಗೊಂಡ್ರೆ ಏನಾಗಿರುತ್ತೆ, that will give you 30 degree, like that. Okay, so you remember the values for some standard angles, so ಅದರ inverse angle na you can back calculate. Okay, so that's what I'm doing here. Any doubts, please ask in the chat box, and if you're following, please give me a thumbs up. Quick response in the chat box. Entire projectile motion is very important. Okay, you cannot skip anything in projectile motion. Anything can be asked for. Definitely one 5-mark question will be there from this chapter. I mean from the projectile motion I can say. Okay, so it's like as I said, only 4 possibility. I'm trying to keep it as simple as possible. So one is trajectory equation, like 3 steps you will get it. The other is maximum height of or the time of flight, which is again a 3-step process. And then you have maximum height of the projectile. This again the same equation, we are applying the condition. I'm not writing any new equations. All these are from your 1D motion. So ಇದನ್ನೆಲ್ಲ ನೀವು ಬೇರೆ ಬೇರೆ ಈಕ್ವೇಶನ್ ಅಂತ ಅನ್ಕೊಂಡ್ಲೇಬೇಡಿ, ಇದೆಲ್ಲ ನಿಮಗೆ ಗೊತ್ತಿರೋ ಈಕ್ವೇಶನ್. ಓಕೆ, ಆ ಸಿಚುಯೇಷನ್ ಯಾವ್ದು ಬೇಕೋ ಅದನ್ನ ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದೀವಿ. ಸೊ ಆಲ್ ದೀಸ್ 4, ಇನ್ನೊಂದು ಯಾವುದು ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಡಿರೈವ್ ನೌ, ದಟ್ ಇಸ್ ರೇಂಜ್ ಆಫ್ ದಿ ಪ್ರೊಜೆಕ್ಟೈಲ್. ರೇಂಜ್, height, time of flight, trajectory equation, all 4 are equally important. Any 2 will be asked for 5 marks, or if it comes in 3 marks, any one they will ask. Is that clear, Akshita? Hope you are following. Any doubt, you please ask there itself, okay, if you are finding it very difficult. Okay, so next is horizontal range of a projectile. So already we found out what is the height reached, that is the maximum vertical distance of the projectile. Now we are trying to find out the range of the projectile. So range andre it is the horizontal displacement, or the total horizontal distance covered by the projectile from the point of projection. That is, if I throw from here, once it comes back to the ground, okay, or the point where it is being thrown, ಆ ಲೆವೆಲ್ಗೆ ಬರೋಲ್ ತನಕ ಎಷ್ಟು ಹಾರಿಜಾಂಟಲ್ ಡಿಸ್ಟೆನ್ಸ್ ಕವರ್ ಆಗಿದೆ ಅದನ್ನ ನಾವು ರೇಂಜ್ ಅಂತ ಕರಿತೀವಿ. ಓಕೆ, ಹಾರಿಜಾಂಟಲ್ ಡಿಸ್ಟೆನ್ಸ್ ಇಸ್ ರೇಂಜ್, ಮ್ಯಾಕ್ಸಿಮಮ್ ವರ್ಟಿಕಲ್ ಹೈಟ್ ಇಸ್ your maximum height reached by the projectile. Okay, so ಎರಡು ನೆನಪಿರಬೇಕು. ಈಕ್ವೇಶನ್ಸ್ ಎಲ್ಲ ಈಕ್ವೇಶನ್ ಇಂಪಾರ್ಟೆಂಟ್, ಬಿಕಾಸ್ ಕಾಂಪಿಟೇಟಿವ್ಲಿ ಡೆಫಿನೆಟ್ಲಿ 1 or 2 ಕ್ವೆಶನ್ ಇದ್ದೇ ಇರುತ್ತೆ ಪ್ರೊಜೆಕ್ಟೈಲ್ ಮೋಷನ್ ಮೇಲೆ. ಸೊ ಆಲ್ ಈಕ್ವೇಶನ್ಸ್ ಆರ್ equally important. Okay, thanks for your response, Rakshita. Hope we will go ahead to the next concept, that is the range. Again, range and rain helde, it is the horizontal distance or the displacement ant helidini. So horizontal andre x axis equation tagolbeku ashte. So x axis equation enu, x is equals to u cos theta into t anta bandide. If I just go back and show it to you, so illide, yeah, illide, I hope you can see this, or adanne nanu illi relabel madirabahudu. Yeah, here it is. Okay, x is equals to u cos theta into t antide, correct? So ಆ equation na ತಗೊಳ್ತಾ ಇದೀನಿ ನಾನು. Okay, because along horizontal direction there is no acceleration. Okay, so repeatedly ಹೇಳ್ತಾ ಇದೀನಿ, ನಿಮಗೆ ನೆನಪಿರಬೇಕು, no acceleration along x axis. Acceleration ಏನಿದೆ ಅದು only along y axis, that is acceleration due to gravity. Okay, so along x axis no acceleration at all. So acceleration illa andre ನಾವು ಹೇಗೆ ಬರಿತೀವಿ, distance traveled. So because we know that velocity is distance by time kind of a thing, or if I want x is equals to v into t, correct? So ade equation of motion na we are writing here. There is no acceleration term. V is equals to u plus at li a at term illa. Okay, okay, I mean x is equals to ut plus half at square, sorry, x is equals to ut plus half at square ತಗೊಂಡ್ರೆ along x axis ಅಲ್ಲಿ acceleration ಇರಲ್ಲ, so ಈ term ಬರಲ್ಲ, x is equals to u into t ಆಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿ u ಅಂದ್ರೆ ಯಾವುದು, along horizontal direction ಯಾವ velocity ಇದೆ, u cos theta ಇದೆ, so we have to take u cos theta into t. Okay, so ಆ ಪಾಯಿಂಟ್ ನ ತಗೊಳ್ತಾ ಇದೀನಿ, and now I know how much time the projectile takes, to complete its flight. So illinda from this point, okay, so e point inda to complete its motion, ground inda maximum height ಗೆ ಹೋಗಿ ಮತ್ತೆ ವಾಪಸ್ ground ಗೆ ಬರಕ್ಕೆ ಎಷ್ಟು ಟೈಮ್ ತಗೊಳುತ್ತೆ, we know it. So just substitute for t. Okay, so ಏನು ಹೇಳ್ಬೋದು, for range ಏನಾಗಿರುತ್ತೆ, x will be equal to r, but ಅದಕ್ಕೆ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಟೈಮ್ ಏನಾಗಿರುತ್ತೆ, t will be equal to capital T ಆಗಿರುತ್ತೆ, which is like 2u sin theta by g. Okay, so ಏನು ಮಾಡ್ತಾ ಇದೀವಿ, so we just had the time of flight equation, this one I am taking 2u sin theta by g. Okay, so time of flight ಗೆ substitute ಮಾಡಿ, x is equals to u cos theta into 2u sin theta by g. Okay, so ಈಗ again ಇಲ್ಲಿ x ಅಂದ್ರೆ ಏನಾಗಬೇಕು, r ಅಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೋಣ. x is equals to r ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತಾ ಇದೀನಿ. ಯಾವಾಗ x is equals to r ಆದ್ರೆ t will be equal to 2u sin theta by g ಆಗಿರುತ್ತೆ, or this will give us r is equals to u square into 2 sin theta into cos theta divided by g ಅಂತ ಬರೀತೀನಿ. I just have rearranged this. Okay, so ಏನು ಮಾಡಿದೀವಿ, this 2 I am writing here, sin theta ಇಲ್ಲಿದೆ, cos theta ಇಲ್ಲಿದೆ. Okay, and this u with this u will give us u square. I just have rewritten. Okay, that's all we did here. So observe ಮಾಡಿ, so there is a trigonometric identity. Okay, so 2 sin theta into cos theta is sin 2 theta. Please remember this formula. I'll just write in this top corner. So sin 2 theta andre, okay, so 2 times of sin theta into cos theta. Okay, sin 2 theta formula 2 sin theta into cos theta. So this whole term in the bracket can be written as ಏನು ಬರಿಬೋದು, sin 2 theta ಆಗುತ್ತೆ. So I'll just substitute here. Okay, so range R is equals to u square sine 2 theta by g. Okay, u square sine 2 theta by g. So this is another very important expression for range of the projectile. Okay, so any doubts you please ask me. So we got three equations. One is time of flight, the other one is range, other one is height. Okay, and also you can consider the trajectory equation. Y is equals to x tan theta minus g by 2 u square cos square theta into x square. Okay, so that is one. And if you want in terms of time, you can remember this y equation. Okay, so this one. Trajectory means it should be in terms of x and y. Hope it is clear till here. Any doubts? Please respond in the chat box. Hope you are following too. I'm just waiting for your response in the chat box. How is your preparation going on for upcoming test? Yeah. When is your first internal test in your college? Can you respond? Yeah, please respond in the chat box. By that time, I'll just give you one more special case here. You can take it as note. So let us consider the range equation. Range is u square sine 2 theta by g. Okay, so range equation u square sine 2 theta by g. Okay, so ಈಗ ಯಾವ ಕಂಡೀಷನ್ ಅಲ್ಲಿ again range will become maximum. ಸೊ ಪ್ರೀವಿಯಸ್ ಕೇಸಲ್ಲಿ ಏನ್ ಮಾಡಿದ್ವಿ, ಯಾವ ಆಂಗಲ್ ಆಫ್ ಪ್ರೊಜೆಕ್ಷನ್ ಗೆ ಹೈಟ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಇರುತ್ತೆ ಅಂತ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿದ್ವಿ. ಸೊ ಇಲ್ಲ ಏನ್ ಮಾಡೋಣ, ಯಾವ ಆಂಗಲ್ ಆಫ್ ಪ್ರೊಜೆಕ್ಷನ್ ಗೆ ರೇಂಜ್ ವಿಲ್ ಬಿ ಮ್ಯಾಕ್ಸಿಮಮ್. Okay, so again u and g are constant, so I can say r is proportional to sine 2 theta provided u is constant for a given value of u. For a given value of u, so ಏನು ಹೇಳ್ಬೋದು, range is proportional to sine 2 theta. So for range to be maximum, ಅಂದ್ರೆ horizontal distance ಜಾಸ್ತಿ ದೂರ ಹೋಗಬೇಕು. Okay, so that is what the condition here. For range to be maximum, so range maximum ಆಗ್ಬೇಕಂದ್ರೆ, so sine 2 theta must be maximum. Hope you agree, because range is completely dependent on sine 2 theta now. Sine 2 theta must be maximum. Okay, so sine 2 theta maximum andre again sine value the maximum eshtu value, I mean sine function in a maximum value eshtu, so that is always 1. Please remember. Okay, sine function in a maximum value 1, sine 90 is 1 na, so that itself is the maximum value. Okay, so it is a periodic function. You go for other higher angles also, it just repeats. It varies from -1 to +1. Okay, -1 0 +1 ಆ ಮೂರು ಆ ರೇಂಜ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. Okay, so sine function a maximum value is always +1. so ಈಗ sine 2 theta is 1 ಅಂದ್ರೆ I can say 2 theta must be equal to sine inverse 1. so previously ಹೇಳಿದೀನಿ sine inverse 1 ಯಾವ ಆಂಗಲ್ ಅಲ್ಲಿ ಆಗುತ್ತೆ, 90 ಡಿಗ್ರಿ ಅಲ್ಲಿ ಆಗುತ್ತೆ. so I can say this ಇಲ್ಲಿ angle 2 theta ಇದೆ, so 2 theta ನೇ ಬರ್ಕೊಳ್ಬೇಕು ನೀವು. so 2 theta will be equal to 90 degree, or theta will be equal to 90 degree by 2, which is nothing but equal to 45 degrees. Okay, so range ಯಾವಾಗ maximum ಇರುತ್ತೆ 45 degree ಅಲ್ಲಿ range will be maximum. so this is one important condition which you can remember for maximum range. so ಇದನ್ನ MCQ ಅಲ್ಲೂ ಕೇಳಬಹುದು ನಿಮಗೆ. what is the angle of projection for range to be maximum? At what angle of projection the range is maximum, or the range is maximum at ಡ್ಯಾಶ್ ಆಂಗಲ್ಸ್. ಸೊ ಆಂಗಲ್ ಆಫ್ ಪ್ರೊಜೆಕ್ಷನ್ ಏನಿರಬೇಕು 45 ಡಿಗ್ರಿಯಲ್ಲಿ ಥ್ರೋ ಮಾಡಿದ್ರೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ರೇಂಜ್ ಬರುತ್ತೆ. ಇಟ್ ಇಸ್ ದಿ ಐಡಿಯಲ್ ಕೇಸ್ ಬಿಕಾಸ್ ನಾವಿಲ್ಲಿ ಏರ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಎಲ್ಲ ಇಗ್ನೋರ್ ಮಾಡಿದೀವಿ. ಸೊ ಇಫ್ ಯು ಕನ್ಸಿಡರ್ ಏರ್ ರೆಸಿಸ್ಟೆನ್ಸ್, ದ ಆಂಗಲ್ ಆಫ್ ಪ್ರೊಜೆಕ್ಷನ್ ಸ್ವಲ್ಪ ಸ್ಲೈಟ್ಲಿ less than 45 degree ಬರುತ್ತೆ for the range to be maximum. Okay, so all these facts are very helpful in your sports as well, like especially in javelin throw. So angle of projection proper iddangunu avara range or the horizontal distance enirutte ಜಾಸ್ತಿ ಬರುತ್ತೆ. Okay, so that is one application in the case of sports. Okay, so range ಜಾಸ್ತಿ ಆಗಬೇಕಂದ್ರೆ angle of projection correct ಇರಬೇಕು. Theoretically 45 degree, practically ಅದು slight differ ಬರುತ್ತೆ. Okay, yeah, hope that is clear. Any doubt? If you have any doubts, please respond in the chat box. So now we'll just quickly take up a problem on this particular concept. There is projectile motion mele one problem madana. A football player kicks a ball at an angle of 30 degree antide. So andre ಏನು ಹೇಳ್ಬೋದು, angle of projection ಕೊಟ್ಟಿದ್ದಾರೆ 30 ಡಿಗ್ರಿ ಇದೆ ಟು ದಿ ಹಾರಿಜಾಂಟಲ್. ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಸಮ್ಟೈಮ್ಸ್ ಇಲ್ಲಿ ಏನ್ ಮಾಡಿರ್ತಾರೆ ವರ್ಟಿಕಲ್ ಅಂತ ಇರುತ್ತೆ, ಅವಾಗ ನೀವು ಹಾರಿಜಾಂಟಲ್ ಇಂದು ಏನಾಗುತ್ತೆ ಆಂಗಲ್ ಅಂತ ನೋಡ್ಕೊಳ್ಬೇಕು. ಓಕೆ, ಥೀಟಾ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು 30 ಡಿಗ್ರಿ ವಿತ್ ಅನ್ ಇನಿಷಿಯಲ್ ಸ್ಪೀಡ್ ಆಫ್ 20 ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್ ಅಂತ ಇದೆ. ಅಂದ್ರೆ ಯು ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿದ್ದಾರೆ 20 meters per second. Calculate maximum height, horizontal range and time of flight. ಮೂರು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ದಟ್ ಇಸ್ ಕ್ಯಾಪಿಟಲ್ H, R and capital T. Take G as 10 meter per second square. ಸೊ ಇಲ್ಲೇನು 10 meter per second square ಅವ್ರು ಕೊಟ್ಟಿಲ್ಲ ಅಂದ್ರೆ ನೀವು ಬೋರ್ಡ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಅಲ್ಲೆಲ್ಲ 9.8 ತಗೊಳ್ಬೇಕು. ಬಿಕಾಸ್ ನಿಮ್ಗೆ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಅಲ್ಲೋ ಇರುತ್ತೆ, ಈಸಿಯಾಗಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೋದು. ಸೊ ಯು ಹ್ಯಾಡ್ ಟು ಟೇಕ್ 9.8. ಬಟ್ ಅವ್ರು 10 ಅಂತ ಕೊಟ್ಟಾಗ ಅಗೇನ್ 9.8 ಹಾಕೊಂಡು ಮಾಡ್ಬಿಡಿ, ತಪ್ಪಾಗುತ್ತೆ ಆನ್ಸರು. ಸೊ ಅವ್ರು ಕೊಟ್ರೆ 10 ತಗೊಳ್ಳಿ, ಇಲ್ಲ ಅಂದ್ರೆ 9.8. ಓಕೆ, ಫಸ್ಟ್ ಯಾವುದು, ವಿ ಹ್ಯಾಡ್ ಟು ಫೈಂಡ್ ಔಟ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಹೈಟ್. ಸೊ ಹೈಟ್ ಈಕ್ವೇಶನ್ ಏನು, ಯು ಸ್ಕ್ವೇರ್ ಸೈನ್ ಸ್ಕ್ವೇರ್ ಥೀಟಾ ಬೈ 2g. ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೋಣ. ಯು ಸ್ಕ್ವೇರ್ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ 20 ಇಂಟು 20 ಇಂಟು ಸೈನ್ ಸ್ಕ್ವೇರ್ ಥೀಟಾ ಅಂದ್ರೆ ಸೈನ್ ಥೀಟಾ ಹೋಲ್ ಸ್ಕ್ವೇರ್ ತರ ಅದು. ಸೊ ಥೀಟಾ ವ್ಯಾಲ್ಯೂ ಏನಿದೆ ಸೈನ್ 30 ಅಂತಿದೆ. ಸೊ ಸೈನ್ 30 ಹೋಲ್ ಸ್ಕ್ವೇರ್ ಡಿವೈಡೆಡ್ ಬೈ 2 ಇಂಟು 10. ಆರ್ ಇದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ. ಸೊ ಏನಾಗುತ್ತೆ 20 ಇಂಟು 20 ಇಂಟು ಸೈನ್ 30 ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು, ಸೈನ್ 30 is half. ಸೊ ದಿಸ್ ಇಸ್ 1/2 ಸ್ಕ್ವೇರ್ ಬಿಕಾಸ್ ಇಲ್ಲಿ ಸ್ಕ್ವೇರ್ ಇದೆ. ಡಿವೈಡೆಡ್ ಬೈ 2 ಇಂಟು 10 is 20. ಸೊ ದಿಸ್ 20 will go away. So remaining term ಏನಾಗುತ್ತೆ 20 by 4, which is going to give you the height reached as 5 meters. Okay, so this is first part of the question. Hope you are following and you got the answer as 5 meters. Any doubts? Next ಏನು ಕೇಳಿದ್ದಾರೆ, horizontal range ಬೇಕು. ಸೊ ರೇಂಜ್ ಫಾರ್ಮ್ಯುಲಾ ಏನು, ಯು ಸ್ಕ್ವೇರ್ ಸೈನ್ 2 ಥೀಟಾ ಬೈ ಜಿ. ಓಕೆ, ಯು ಸ್ಕ್ವೇರ್ ಸೈನ್ 2 ಥೀಟಾ ಬೈ ಜಿ ಇದೆ. ಸೊ ಅಗೇನ್ ಯು ಸ್ಕ್ವೇರ್ ಅಂದ್ರೆ 20 ಇಂಟು 20, ಸೈನ್ 2 ಥೀಟಾ ಅಂದ್ರೆ ಸೈನ್ 2 ಇಂಟು 30 ಡಿಗ್ರಿ ಹೋಲ್ ಡಿವೈಡೆಡ್ ಬೈ 10. ಓಕೆ, ಸೊ ಇದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ. ದಿಸ್ ಇಸ್ ಲೈಕ್ 10 1s are 10 2s are. ಸೊ ಇಲ್ಲಿ 2 ಇಂಟು 30 ಅಂದ್ರೆ 60. ಸೊ ಸೈನ್ 60 ಆಗುತ್ತೆ. ಕರೆಕ್ಟ್, ಸೈನ್ 60 ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು √3/2. ಓಕೆ, ಸೊ ಏನ್ ಬರುತ್ತೆ ನಿಮ್ಗೆ 2 ಇಂಟು 20 ಇಂಟು ಸೈನ್ 60 ಅಂದ್ರೆ √3/2. ಸೊ ದಿಸ್ 2 and this 2 will cancel out. ಸೊ ಏನಾಗುತ್ತೆ, I'll just write here, hope you can see this. Range is equals to 20 √3 meters. ಸೊ ಇದೆಲ್ಲ ಡಿಸ್ಟೆನ್ಸ್ ಮೀಟರ್ ಅಲ್ಲೇ ಇರಬೇಕು ಫೈನಲ್ ಆನ್ಸರ್. ಓಕೆ, ಯಾ ಯು ಶುಡ್ ರೈಟ್ ದ ಯೂನಿಟ್ 20 √3. ಓಕೆ, ಸೊ ವಿಲ್ ಬಿ ದ ಫೈನಲ್ ಆನ್ಸರ್. ದಟ್ ಇಸ್ ದಿ ರೇಂಜ್. ಹೋಪ್ ಯು ಆರ್ ಟ್ರೈಯಿಂಗ್ ಔಟ್. ಎನಿಬಡಿ ಗಾಟ್ ದಿ ಆನ್ಸರ್? 20 √3, or this will come around 34.64 meter ಅಂತಾನು ಬರಿಬಹುದು. ಸೊ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಇರುತ್ತೆ. ಯಾ ಯು ಹ್ಯಾಡ್ ಟು ಡೂ 20 into √3. ಓಕೆ, √3 is 1.732. ಆ ಥರ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರು ಆಗುತ್ತೆ ಡೈರೆಕ್ಟ್ ಆಗಿ. ಓಕೆ, 34.64 meters ಆಗತ್ತೆ ರೇಂಜ್. ಓಕೆ, ಇನ್ ಒಂದು ಕ್ವಾಂಟಿಟಿ ಇದೆ, ದಟ್ ಇಸ್ ಟೈಮ್ ಆಫ್ ಫ್ಲೈಟ್. ಸೊ ಲೆಟ್ ಮಿ ರೈಟ್ ಹಿಯರ್. ಟೈಮ್ ಆಫ್ ಫ್ಲೈಟ್ ಫಾರ್ಮುಲಾ ಏನು? T is equals to 2u sin theta by g. ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ. 2 into u ಅಂದ್ರೆ 20 ಅಲ್ವಾ? ಯಾ, 2 into 20 into sin 30 degree divided by 10. G andre 10. Okay, so this is like 10 ones are 10 twos are. So this will give you 4 into sin 30. Sin 30 as to half. Okay, which is just going to give you 2 seconds agatte. Final answer 4 by 2 is 2 seconds. Okay, any doubts? So this is how you solve problems in the case of projectile motion. Okay, any doubts? So height, range, time of flight. Okay, if you have any doubts, you can ask in the chat box. Hope no doubts till here. So if 2 seconds is the time to reach, time of flight, so then time to reach the maximum height ಏನಾಗಿರುತ್ತೆ? 1 second ಆಗಿರುತ್ತೆ. That you can, cross check. Okay, u sin theta by g. Time to reach maximum height is u sin theta by g. So time of ascent, that is time to go, in its upward journey, will be equal to time for its downward journey ಆಗಿರುತ್ತೆ. Okay, symmetric parabola, correct? So about the maximum height, the parabola ಏನಾಗಿರುತ್ತೆ? ಅಲ್ಲಿ symmetric ಇರುತ್ತೆ. ಸೊ 0 ಇಂದ ಮ್ಯಾಕ್ಸಿಮಮ್ ಹೈಟಿಗೆ ಏನು ಟೈಮ್ ತಗೊಂಡಿರುತ್ತೋ ಮ್ಯಾಕ್ಸಿಮಮ್ ಹೈಟ್ ಇಂದ ಗ್ರೌಂಡಿಗೆ ಸೇಮ್ ಟೈಮೇ ತಗೊಂಡಿರುತ್ತೆ. ಓಕೆ, ಸೊ ಅಲ್ಲಿಗೆ ಟು ರೀಚ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಹೈಟ್ ಇಸ್ 1 second and from there to come back to ground again 1 second. Total time 2 seconds. Okay, hope it is clear till here. Yeah, so one simple problem is there. I'll just want you to take it as a homework and try it out. Okay, you can also, if you don't get the answer, we can discuss in our next class. So ಇಲ್ಲಿ ಏನಿದೆ, angle of projection ಕೊಟ್ಟಿದ್ದಾರೆ 30 degree with the vertical. This is very important. So I'll take this as something else. Okay, beta is equals to 30 degree ಅಂತ ತಗೊಳ್ತೀನಿ. Horizontal component of velocity ಕೊಟ್ಟಿದ್ದಾರೆ, ಅಂದ್ರೆ ux value ಕೊಟ್ಟಿದ್ದಾರೆ. Okay, so you have to find out maximum height and horizontal range. ಸೊ ಇಲ್ಲಿ ಅಲಾಂಗ್ ವಿತ್ ದಿ ವರ್ಟಿಕಲ್ ಕೊಟ್ರೆ ಏನ್ ತಗೊಳ್ಬೇಕು? ಥೀಟಾ ವಿಲ್ ಬಿ 90 minus ಬೀಟಾ ಆಗಿರುತ್ತೆ. ದಟ್ ಇಸ್ 60 degree ಆಗುತ್ತೆ. 90 minus 30. ಓಕೆ, ಬಿಕಾಸ್ ಆಂಗಲ್ ಆಫ್ ಪ್ರೊಜೆಕ್ಷನ್ ಇಸ್ ಆಲ್ವೇಸ್ ಡಿಫೈನ್ಡ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಹಾರಿಜಾಂಟಲ್ ಡೈರೆಕ್ಷನ್. ಸೊ ಈ ಹಿಂಟ್ ಇಟ್ಕೊಂಡು ಟ್ರೈ ಮಾಡಿ. ಓಕೆ, ಸೊ ಇಫ್ ಯು ಡೋಂಟ್ ಗೆಟ್, ವಿ ಕ್ಯಾನ್ ವರ್ಕ್ ಔಟ್ ಇನ್ ಅವರ್ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಆಸ್ ವೆಲ್. ಸೊ ಪ್ಲೀಸ್ ಟೇಕ್ ಇಟ್ ಆಸ್ ಎ ಹೋಮ್ವರ್ಕ್. ಎನಿ ಡೌಟ್ಸ್? If you have some doubts, you can just ask in the chat box. Hope you will try this problem. Okay, I think there are no doubts. Okay, if there are no doubts, I'm just going to end the session for the day. If you understood the concepts that are discussed in today's session, you please like the videos and give me a thumbs up. Okay, and also subscribe to our channel. Okay, have a good day ahead. Take care.